So here we are over in Maya, and I've set up a very simple n-particle system. So using Maya's particles, if we go to the effects tab here, we can see that we've got various effects menus, and these are all the different modules that we have in Maya. If we actually go to the particles menu, you can see that Maya has legacy particles and it also has n particles. So there's two types of particle system that we can choose from. They both pretty much behave in the same way in Maya, although they don't really interact with each other. The reason we have these n particles now was Maya's way of trying to make a unified solver, so that various effects can actually interact with each other. So the n particles are part of the nucleus solver here. This is the nucleus node, and the nucleus solver will solve cloth, some form of rigid bodies, and also particles, and all of these things are bidirectional. They'll all interact with each other. So what I mean by that is the particles will push the cloth as much as the cloth pushes back the particles. So the main drawback of Maya's different modules is actually getting them to interact with each other, because they don't really share the data readily between those systems. I mean, a brief look at the n-particle system, for example, is you would create an emitter or have some geometry that the emitter is attached to, and then the emitter generates some particles, and the particles collide with other passive objects that are connected to the nucleus solver node. And if we have a look at the network that's created from this, let's just expand that out a little bit. You can see it's a little bit complicated with lines shooting everywhere. You can kind of work out the important nodes that you want to select, but as I've mentioned before, it's not really designed to be manipulated in the graph editor here. It's ideally you want to choose things in the outline and select edit things in the attribute editor here, and there you've got all your plenty of tabs. And trying to access or share this data between other parts of the system is quite tricky. For example, say I wanted to get these particles to deform this ground when they hit it. I could potentially turn this into n-cloth and get these to dent it when they hit it, which would be quite slow, to be fair, to get the fidelity that you would need. Or you could write some clever scripting to do the same effect, but it's not a trivial problem. Let's have a look at the similar sort of particle system inside Houdini's context. So here in Houdini I have pretty much the same system, a bunch of particles spewing out the rotating sphere, and they're colliding with the floor. And we can see how the DOPS context is working here with SOPs, and how that can give us some interesting power and access to the data. So first off, let's look inside our sphere object. I'll just leave that play for a minute. So look inside the sphere object, you'll see we have a sphere, and then in the SOPs I've created an attribute for velocity to give it some velocity to shoot the particles out in a particular direction. This geometry is getting sent into this object, which is our DOP network. So within here is the DOPS context. So if we go inside there, in fact you'll notice at the top right here it says which context we're in. This is dynamics. If I come up here, this is the object level. So in Houdini we make various objects, and then we can go inside to edit those contexts, as I mentioned before. So if I go inside the DOP net, it does in fact say dynamics, and we've got our own suite of nodes to deal with everything dynamics, including pyro and rigid bodies and everything else. And since all these solvers are within the same context, all the solvers will talk to each other and be bidirectional. Unlike Maya, where they have to actually be connected to the same solver, the different modules don't communicate as easily. So you'll notice the visibility flag is not on for this node. We're not displaying this node. We're merely calculating all the particle information. We're then returning that particle information back into this node. If I see, back into SOPs, if I just turn the visibility flag off. So if I go inside, you'll see we have a DOP.io. So this is returning the particle data from the dynamic context, so we can do further stuff with it. We can either render them or use them for other stuff. And as you can see, I've added a bit more of a network in SOPs here. I've created a grid. I've given the grid a color. Let's just pause this for a minute. I've also got my particles here. Let's put those about there. I've given them a color. And then we're using this solver node to create an effect with these particles. So what this does is, as the particles hit the ground, you'll see the solver node gets them to accumulate some color on there. That's quite a simple effect, really. If I look inside, all I'm doing is basically creating an attribute. We're transferring that attribute over to the grid here, and then I'm doing some maths here to accumulate that value into the color, and then we're just making sure the ranges are set right. And you'll see that the color accumulates. This could be used for a wet map or a paint map. And then this node here is taking that color and just pushing the points along in that direction, creating a deformation type effect. So as you can see, it's fairly simple, again, once we bring the data back into SOPs, to being able to then manipulate further SOP geometry with the data from the particles in Houdini. This is the advantage of sort of using multiple contexts, bringing it back, and just having control over everything. So let's compare some of the other dynamic modules.